All right, so what do we have here? We have the extra credit twin. All right. Do it or don't do it. Kind of up to you. This is the extra credit twin. Nobody says you have to do it. Preferably you do. I wonder if it's recording. Can you hear me? All right, I usually do that first. Anyways, we got another graph. First question is the range. This thing has a low value of 0, and it rises to 4, and then we have to make a jump. Hopefully you've done some of that Milbrath-Math and you're getting your brackets and stuff down. We have a low value of 0, we rise to 4, and then we jump up. Now, even though there's an open hole here, it's solid there. And we just contain a y value of 6. A little different than Milbrath-Math. Milbrath-Math would have you say 6, 6, but that's just because that's the way the software is written. Next up is domain. This thing starts over here at -6 with solid dot, runs all the way to -2 with an open dot, and then there's actually a horizontal jump to 0, where x is 0. And then it runs to 5, and you make a vertical jump, not a horizontal jump, a vertical jump. So it runs from 0 to 5 on to 7. And then it stops. All right, there's no arrow. It stopped. Intervals where the graph is increasing. The only interval I see where the graph is increasing would be here from the x value of 2 to 5. Those always use parentheses, just the way they are. X-intercepts, that's going to be where we cross the x-axis. It's going to be right there. It's at 2, 0. Y-intercept is going to be right here. Even though it doesn't cross, it's touching, still touching. 0, 2. Average rate of change from -3 to 0. So a lot of kids struggle with this. We're going to go to -3 and we're going to put a dot on the graph. And then we're going to go to where x is 0 and we're going to put a dot on the graph. And we're going to realize that we fell 1 and we ran 3. That's how hard that is. F of 5, when you go to where x is 5, you can be this guy or this guy, and there's literally a hole. There's nothing in that hole. So the y value is 4. Where is the graph decreasing? The graph is decreasing there from x values of 0 to 2. Where is the graph positive? Positive again means above x-axis. The graph's positive everywhere, isn't it? It's positive from here to here, there, and there. It's essentially the same as the domain. It is positive from -6 to close to 2, union with 0 to 7. And I should not be using brackets on that, forgive me. -6 to -2, union with 0 to 7. Brackets are only supposed to be for domain and range, although sometimes people do it with that. Where is she negative? Never. It's not. Negative means below the x-axis. You might see me abbreviate at some point in time. Does not exist. And I would abbreviate that literally DNE, does not exist. So that's how I would do the first 11. Hopefully those go better than they have been in the past. All right, what do we have here? We have the graph y equals negative absolute value of x minus 3 plus 4 is reflected across the x-axis. Write an equation of the reflected graph, and what you can do is you can know that this means that the function is going to negate the original one. So I would put a negative symbol, wrap the entire given function, and then I would distribute. A negative times a negative is now positive. and a negative times a positive is now negative. I could do that. Or I could graph. And graphing makes a lot of sense to me. It did when I was younger. But if I graph the original equation, I'm right 3 up 4. And I have a negative slope. So I look like that. If I reflect over the x-axis, I'm taking what's above and making it below. It'll still be right 3, but it'll be down 4. And instead of opening down, I'm going to open up. And maybe you can kind of make that connection between those two equations. Right 3, down 4, positive slope. It's supposed to be a plus symbol. That probably won't go so hot on your quiz, but it is what it is. Over what interval is the graph y equals -2 plus the absolute value of x minus 4 decreasing? I'm going to put that in the form you were taught to graph. And I'm going to take a look at the picture. It's a right 4, down 2. This is right 4, down 2. Forgive me if I'm going so fast. I only have like 20 minutes before I have class. And I'm tired. And the only reason I'm doing this for y'all, giving you 2 twins and extra credit, is because you need to practice, and I probably won't be here a whole lot next week, so you need to be practicing. And there we go. That's what she looks like. She's decreasing here. And that is literally, that is where x is less than 4. Now I want an interval. If I'm less than 4, I can be 3, I can be 2, I can be 1, I can be 0. I can move left forever to negative infinity all the way to 4. And that's what I'm looking for, is an interval. Moving on to 14. Identify the transformations of the parent function f of x is absolute value of x that gives g of x being 3 plus 2 times the absolute value of 2 times x plus 2. So again, the first thing I'll do is I'll put g of x in a standard form. I'm just going to rearrange things. Then I'm going to line up with our form of a f's b x minus h plus k. We'll just go through and talk about the letters here. A is 2. Okay. That is a vertical stretch. Factor of 2. Literally twice as steep. What it means. B is 2. It's inside, so it's opposite of what you think. This is a vertical, sorry, not vertical. Inside is about the horizontal. So horizontal compression literally means half the width. H is 3. It's inside. Again, it's opposite of what you think. We don't shift to the right. We shift left 3. Then we have K. K is on the outside. Anything on the outside you can trust. It works the way it's supposed to. And K is 3. This is a vertical shift up 3. Ta-da! Move on. 15 is graph the piecewise function. You know, these guys right here, those are horizontal lines. You're supposed to know your moms. It's not my fault that you don't. That's yours. We've been over these things. Y equals a constant is a horizontal line. You know, just like that. So y equals -3 would be down here. -3. Y equals 4 would be up at 4. And it'd be like that. You also have this guy in the middle, y equals 3 minus x, which you might think of as -x plus 3. And by God, somebody taught you mx plus b once upon a time. It crossed the y-axis at 3, and then it would fall because it has decreasing negative slope. So the only thing I'm actually going to make a table for on this one is this guy. That's the only guy I'm going to make a table for. Y is -3 if x is between -1 and 2. That's pretty nice. So -3, -1, all the way to 2. Notice they're both open holes because of this. Oh, that one's closed. I am 3 minus x. If I am between 2 and 4. Oh, I cannot think today. Let me go back several steps here. Let's try this again. I am 3 minus x if x is stuck between 2 and 4. 3 minus 2 is 1. 3 minus 4 is negative 1. These are both closed. So 2, 1 is going to be closed. 4, negative 1 is going to be closed. And then I'm this guy. I'm 4 as long as x is bigger than 4. Open hole, run right forever. What's the piecewise function? It ain't too bad. It's not as bad as you want it to be. 16, we got to write the equation for a piecewise function. It's in your first rodeo, this thing. This literally looks like mom. I mean, that is x squared. There is no doubt that is x squared. And this is y equals 3. And if we think about this one, this is y equals x. It's got 3 pieces, obviously. The pieces were x squared, 3, and x. X squared was drawn from, for all values of x less than or equal to 1. 3 was drawn from x values of 1 to 2. Equality on the 2. No equality on 1. And y equals x was drawn as long as you were moving right from 2. Forgive the 4th period class next door, they are always loud. Which of the following series are arithmetic? That means we have a common difference. So this is a difference of negative 14, and then we have a difference of negative 10. That's not common. So I'm not choice 1. This is add 1, and this is take away 39. Not common. I realize y'all's working with fractions is pretty rough, but the difference between 1 and 2/3 is a third. Math answer frac. Sorry, I did this wrong. We're going from 1/3 to 2/3. The difference between 2/3 and 1/3 is a third. The difference between 2/3 and 1 is the same thing. The difference between 4/3 and 1 is also the same. So we have a common difference equal to 1/3. We are that one. This one, numbers look funny, but they're obviously getting smaller. 1 minus 11/12 should be a 12th. Then we have 11/12 minus 5/6, also a 12th. You might not know it when you first look at it, but the difference is 1/12. We are subtracting. So we're also choice 4. '18 is write the first 4 terms of the sequence. And again, these recursive rules, you have the first term, then you have a sub n minus 1 plus the difference. Provided n is 1, provided n is bigger than 1. So there is your first term. There is your difference. This is not rocket science. The first term is 15. The second term is 15 minus 3, which is 12. The third term is 12 minus 3, which is 9. See, I'm following the same thing over and over again. The fourth term is 9 minus 3, which is 6. That's what we're looking for. Those are your 4 terms. Easy peasy, kids. 19 is find the sum. Now, I'm pretty tired. I don't know that I want to do the formulas on this one, but as easy as this is, you could just figure out the pattern. We're adding 7. So we'd have a 26, then we'd have a 33, then we'd have a 40, we'd have a 47. We'd have a 54, we'd have a 61, we'd have a 68, we'd have a 75. Is this lower level thought? Yes. Will kids still miss this? Yes. What am I now? 96, add 7 more, plus 103. So let's see what that is. 5 plus 12 plus 13 plus 26 plus 33. I don't like stuff like this, but I can usually come up with the equations in my head pretty quick. This is slower to me. When I teach, it seems like it takes forever, but that's just me trying to show you what's going on. 810. That is a perfectly valid strategy for a test. Don't think it's not. Explicit rule is going to be a sub n is a sub 1 plus d times n minus 1. There's the first term. The difference appears to be add 9. You know, I know some of y'all struggle, but if you do 5 take away a negative 4, you're going to get 9. And if you do 5 plus 9, you're going to get the next term. So that appears to be legit. So we're going to plug that in for the difference. We've got a negative 4 for the first term. We have a 9 for the common difference. And we know the distributive property like the back of our hand. Hopefully we know how to add negative 4 and negative 9 sums to be negative 13. And we like nx plus b. There you go. Final answer. 6 to go. What do we got here? In a theater, there are 64 chairs in the first row. Each row has 5 more chairs than the previous row, and there are 30 rows. How many chairs are there in the theater? So it's saying add them all up. It's saying find the summation. It's saying find the sum of n terms. And she is n over 2 times first plus last, which is written a sub n. There's 64 in the first row. It's going in. There's 30 rows, that's n. That is the difference, which doesn't go in this formula. But what I know from reading the text is that there's 30 rows. The first one has 64. It's a big theater, by the way. And I don't know that you want to write this out. You can, but don't know that you want to. So let's plug some crap into our little formula. First term is 64. And there's 30 rows, so I'm actually finding a sub 30. The difference was 5. 30 minus 1. And you know, you can just push buttons on that, kids. My brain is shot right now. I do know that 30 minus 1 is 29. I do know that. 209 chairs in the left row. So plus 209. And let's see here. Let's just make sure I don't make any mistakes on y'all because y'all will blindly copy my mistakes. 30 over 2 is 15. In parentheses is 64 plus 209. It's a very large theater. 4,095 seats. Use a graph to solve. So if I look here, I have a right 1, up 3 situation. The slope is rise 1, run 3. It's absolute value. You can get away with it. And put lots of points. That's probably enough points. Still not quite right. Hopefully it's good enough. And the other one's just straight up absolute value of x, which is rise 1, run 1, forever. There's going to be a spot. Backwards. There's going to be a spot. So let's see what my x values are. I have an x equals a 4, and I have an x equals -5. You know, some things are not too hard to solve by graphing. They're not. Some things can be solved easier by graphing than they can by doing by hand. 23, solve the system of equations algebraically. The goal here, and I probably didn't do this on the last video because the last one was so simple, but the goal is to multiply one or both equations by some numbers so that one variable is what we call the additive inverse of another. All right. So glancing at this one, I think what I'm going to do is I'm going to take the top one and I'm just going to take the bottom one and I'm going to times it by 6. I was actually looking at y. So I'm going to leave the top one alone. And you can do this any way you want. You can play with both equations if you want. You could have doubled the top and tripled the bottom and done it for x. It's up to you. Nobody's saying that. But I'm going to multiply the bottom one by 6. That'll give me 12x minus 6y. And 6 times 16 should be 96. And now they are, y is an additive inverse. There's 15x, and it's going to be a horrible looking number. 12 and 96 is 108. So x is going to be 108 over 15, and that ought to reduce. That ought to be divisible by 3. I feel like it's 36/5. Seems right. And now that I have x, I just plug it in. That's all I do. It doesn't really matter what equation you plug it into. And you have access to a calculator on this test, so it doesn't matter that the numbers are bad. We'll just put it right there. So we have 3 times 36/5. I like fractions. 108/5. By the way, I knew that. I was just showing you that you can push buttons. We're going to take that away from 12. And then we're going to divide out that 6. Sometimes. 2 minutes. I got -8/5. So my ordered pair here, because this is how this will be answered, is 36/5 and -8/5. I was hoping to finish this so I could take a lunch break. It's just not going to happen. We got a technology problem. This is a Y1, and this is going to be Y2. If you don't have a calculator, the librarian will be happy to give you one. She'll even change the batteries for you when the batteries die. I've evidently been typing on this one earlier. So I went to y equals. I should probably walk you through that. I saw a -3, I typed a -3. I saw absolute value, I went to math, num, abs, x minus 2, arrow out, +5. To pull up that fraction right there, I went to math, num, n over d, and I pressed enter. Okay. Anyways, we're going to do a zoom 6 because that's how I want you doing things. But what do I know? Your test hasn't been designed so that you have to play around with the windows. I'm not going to do that to you on your first test. Here's my graph. All right, so I need to find these intersections. That's second trace 5. Get your cursor in the neighborhood, press enter 3 times. you're going to get negative 0.6332. So one of my values here is x equals negative 0.6332. Or let's see what my other one is. Second trace 5. Get close. I'm just holding that button down. Enter 3 times. 3.5917. Make sure you can round. 3.5917. I will take off if you can't round. I will. It says nearest 10 thousandths. It's pretty clear on it. And that was the bell just a minute ago, which means it's time for fifth period.